Hello everyone, Jeff Uter from FireEye here. Today I'm going to show you how FireEye's HX can both detect and prevent the Wannacry ransomware on your endpoints. Before we start the demo, I'd like to give you a brief overview of the different methods that the HX agent uses to detect evil. The agent keeps a local ring buffer of events on each endpoint. The ring buffer logs 7 categories of events: changes to the file system, changes to live memory, changes to persistent mechanisms in the registry, as well as DNS lookups, IP address connections, URL events from browsers or other processes, and application behavior. Whenever events in the ring buffer match the agent's indicator compromise library, or when a monitored application's various behaviors add up past a certain threshold, the agent will issue an alert and automatically deliver a focused timeline of events before and after the compromise. The technology used to uncover application exploits is called Exploit Guard and is derived from FireEye's multi-vector execution engine on the other appliances, like the NX and EX. This allows the agent to monitor the most commonly exploited applications for the duration of their lifecycle, like Microsoft Office, Adobe, Java, Flash, and web browsers. Whenever these applications exhibit exploit-like behavior, the HX agent can automatically terminate the application and prevent additional malicious actions from taking place. This technology is part of the reason why FireEye has uncovered more zero days than the rest of the industry combined, and why it can prevent things like Wannacry from obtaining a foothold in your environment. Okay, let's get to the demo. I have two virtual machines set up for this. On one, I'll allow the ransomware to execute and do its thing, and on the other, I'll show how HX's exploit guard can prevent this threat. On the first machine, I go to run the ransomware as a standalone executable. This means Exploit Guard will not be monitoring the process, as it didn't spawn from one of the previously mentioned applications, but the agent will still be logging system changes to allow for IOC or antivirus alerts. The results for infection and detection here would be identical on machines that were compromised through lateral movement via the SMB vulnerability. All right, here we go. WannaCry sample is running, and it looks like the encryption process has begun. And there we go. Okay, so we should get an alert in the HX console for this threat. So let's pop on over to the alerts page, and this should show up in just a moment. Okay, looks like we got the alert for this machine that just got encrypted. And we can see we have 3 different types of indicators that are firing on this alert. So we have some execution events that are flagging the WannaCry ransomware family indicators. We also have some presence alerts on the files that are part of this ransomware family as well. We also have an alert for a Tor tunneler. We can see the portion of the indicator compromised for that. And also interesting, we have an indicator for a methodology class of alert. So these methodology indicators, these are not specific to certain attack tools like the family IOCs or the tunneler IOC is for. These simply refer to any kind of methodology that can be used as part of an attack, regardless of what type of utility is being used to compromise a machine. All right, so even though the files on the system are now encrypted, the HX agent is actually still functional. And I can contain this machine to prevent this threat from spreading to other machines that might have the SMB vulnerability. So if I go ahead and approve that containment request and I bring my VM back over, we can see the clock counting down here. And in just a few moments, this is going to stop, which indicates that my machine has been contained and this threat can't go anywhere else. Now, you're probably thinking, what if my SOC analyst is playing Galaga or something and isn't paying attention? This could spread faster than a human could react if it wasn't initially blocked by Exploit Guard. But that's not a problem because every action you can take here in the GUI can be automated with HX's REST API. Our latest cloud security solution called Helix actually has automation built into it. So if you wanted to, you could actually set up an automation rule to automatically contain any machine that issued a Wannacry or other type of ransomware alert. So in the time it took me to talk about that, looks like the clock has stopped, and this machine has been completely contained off of all network connections. So this thread isn't going anywhere. All right, now to show prevention. On this machine, I'm going to execute the same WannaCry sample that I did on the other machine, but this time I'm going to run it through a Word macro. Now, this is a much more realistic deployment method, as the real-world victims aren't typically going to download a standalone executable and run it. They're more likely to be compromised through an exploited document or an embedded Flash or Java object in a web page than just a standalone exe. So I'm going to open up this Word doc and enable the macro. And it's going to ask me to select a file to run through a macro. So I'm going to grab that same WannaCry sample. And there we go. Exploit guard detects that immediately and terminates Word. You can also see that it terminated the follow-on process that was trying to start to begin encrypting this machine. So let's go ahead and go back to our alerts and see what kind of events we got for that. Okay, looks like we just got our alert for the blocked WannaCry sample. So we can see that, again, we have an IOC firing for this ransomware family, but the main item of interest here is the blocked exploit event. So if we zoom in on the behaviors that the agent logged, we can see that an executable file was created in a temp folder suspiciously, and then it was apparently run as process, and a new registry entry was created. And at this point, the agent says, all right, these behaviors add up together equal application exploit behavior. So it then terminated the exploited application, in this case Word, and it also terminated any follow-on processes after that. So even though, and not only did it terminate the one app, but it also killed anything else spawning out of that. So this system is fine. Uh, we can see that there's no encrypted files or ransomware alert on it. The threat has been prevented, and analysts can look at a timeline of events that the agent's sending over here if they want to. But otherwise, this system is good to go, and that threat has been stopped. So this concludes the demo. Thanks for watching.